Hello, the topic for this video is class attributes. So let me present that. Okay, so all the attributes that we've talked about up to this point are instance attributes. Right? What instance attribute means is that each instance of a class has its own copy of that attribute. So we've seen this, and we typically create so basically for the car class, one of the instance attributes is the make of that class. So, and obviously the reason that each car has its own make is that each car can have a different brand, right? Some car is made by Honda, some car made by Toyota, others by Tesla, etc., etc. So that's why the make of the car class is an instance attribute. Now, we've seen how to create an instance attribute, and typically that's done in dunder init. And to create an attribute, we start with the self, the instance dot make on the left-hand side of an assignment operator. And what that does is that it will create the attribute in that instance if the attribute doesn't already exist. If for whatever reason the attribute already exists, then it'll update that the value for that attribute. Right? So this is on the left hand side or for the right axis of an instance attribute. Now, in this method, in the dunder string method, we want to just print out the make of the car, and this type of access is a read access, right? We're not changing the make attribute, we are reading it and printing it out. So that's a read access and or a right hand side of an assignment operator access. Well, there's no assignment operator here, so it's basically just a read access. Now, this type of attribute, when you try to read it, it obviously must already exist. If it doesn't, you're going to get an exception or an error. Okay, so that's what we've done so far. Now, we've also seen what we called class symbolic constants, right? These are constants, basically constants capitalized, but they don't necessarily make sense outside of the context of class. That's why we make it part of a class. Okay, so and we access these constants by dereferencing the class, right? We don't dereference. Well, here we don't dereference through the instance. We dereference it through the class. Now, so more broadly, really a class symbolic constant, the way we define it, is really just an example of class attributes. So these class attributes, as we already saw, they're defined as part of the class. So they're indented inside a class, but they're not inside a method, right? This is outside a method, but inside class. And because they're not inside any sort of method, we don't really create it by self dot attribute, right? Those are instance attribute. So yeah, that's why they are class attributes. Again, they're part of the class, not inside the method, not created through an instance. And they are accessed, like we've already saw, by dereferencing the class dot the name of the attribute. Okay, so just kind of a formal definition of class or what they're used for. Well, first, class attributes there is only each class attribute. There is only one copy of it for the entire class. So, in other words, they are shared by all instances of the class, right? Each instance of class does not have its own copy of the class attribute. They're all just share the same copy. So what are class attributes good for? Well, we already saw that. So one use case for class attributes is it's symbolic constants in the context of the class, right? Another example we're going to get to in just a bit is we will also use class attributes for class-wide data that are shared by all the instances. Okay. Now, before we show an example of that, I just want to say one thing about the terminology. Class attributes, they are also referred to as static attributes, particularly in languages like C++ and Java. And also, I think in the readings, it also used the word static attribute. But I think class attribute is the term that is more commonly used in Python. So in this class, we're going to try to stick to, excuse me, the term class attribute. Okay. Now, so let's give an example for what kind of class-wide data we might want to be represented by class attributes. So let's say if we want to track the number of cars made. So in other words, we want to track the number of instances of the car class that has ever been created. So obviously, this kind of information is not associated with any one car, right? And or another way to think about it is it's the number of cars ever made is the same for every single car, right? Because yeah, so that's why the number of cars or the number of instances of the car class should just be a class attribute, right? Okay, so the way we do it, so let me just put up my IDE there. We created again inside a class, but not inside a method. So I'm going to just say number of cars. I'm going to initialize it to 0. Usually that makes sense, right? At that point, I don't know how many instances of car have been created. So to start with, I'm going to set it to 0. Okay. Now, where then should we update it? Right? When you want to think about the information that this variable tracks, we should increment it by 1 every time that a car instance is created, right? So then should I do so here? I created 2 cars, so should I increment the number of cars by 1 every time I create an instance of the class? Should I do that? Now let me print this out. Number of cars equals format car dot number of cars. Okay, so one thing to know, this should be obvious that in order to access a class attribute outside the class, we start with the name of the class and then dereference the class and then dot that class attribute, right? That shouldn't be surprised because class attribute is part of a class. So if I run this, yeah, it should work, but is this the right place to do it? So think for a moment. We should have enough experience to say to offer an opinion one way or the other. Is this the right place to increment the number of cars? Well, it's not. because for a number of reasons that we kind of mentioned previously when we talk about instance attributes, right? So first, first reason is if we increment the number of cars outside the class, well, the client, by the client might just be evil, and the client doesn't want to increment it for us, right? The client might want to mess up our accounting. So that's one reason we probably don't want to do this, or we don't want to rely on the client to do this. Well, another reason is again, maybe the client is not evil, but he might be just kind of ignorant or might be careless and just forget to increment it, right? I mean, imagine I'm creating like 100 cars here. I mean, it's a lot of work to remember to increment it for every single one of them, right? And then lastly, maybe the client is not evil, the client is not stupid, but it's probably not the right thing that we burden the client with this kind of requirement for the class that we're writing, right? Um, so, and this is really, as I've said a number of times, this is kind of the internal details or internal requirement for our car class. So it's really the job of the person, the programmer who is writing the class car to increment the number of cars every time an instance of the car is created. So given that, what would be the best place to do it, to increment the number of cars? I mean, think about it for a moment. Shouldn't be that hard. So the best place to do it is in the dunder init, right? Because dunder init is called once every single time an instance of the car is created, right? So we can do that. So instead of doing it here, well, I'm just going to delete that. I am going to, in the dunder init, I'm going to say car.number of cars equals car.number of cars plus 1, right? Every time a car is created, it's called dunder init, and we increment that. And so let's run this. When all works well, I mean, it's a lot cleaner. We don't have to rely on the client to do it. And so this is the good place inside the dunder init. Okay, so now there's something that's sort of kind of interesting about class attributes that we have to talk about. This is what we said a little earlier, that the class attributes are accessed by dereferencing the class. Okay, so we put the class name here, car dot, right? As it turns out, this is not the whole truth. It is true, but it's not the whole truth. Another way to access the class attribute is actually through the instance itself. So we can, well, actually, maybe not here. Hold on. We can, for example, in set price, right? We want to check to make sure the price isn't below the minimum price. Instead of saying car here, I can actually say self, and it's okay. And so the way it works is I'm gonna say, oops, car 1, set price. I'm gonna set it to a negative number, and then I'm actually just gonna print it. Okay, hold on. I'm gonna put it up here. Okay, I'm gonna set it. It really should not allow me to set it because that's below that's below the minimum price, which is 1. So it should not allow me to do it. It should return false here, and then the price of the car doesn't change. So let's run it and see if that's the case. It returns false. I didn't print out the price. But anyway, so yeah, so it kind of shows the it kind of proves that yeah, we can still see the min price as being 1 here. Actually, I can print it out here. Min price is, so format, so min price, right? So the min price when accessed through the instance is 1, okay? And the way that it works is that Python, when it looks at instance dot name, it will first look up this attribute in the instance itself. Okay, if it doesn't find it in the instance, it will go to the class of the instance and see if it has a class attributes by this name, and in this case it does. So that's how it's able to find min price, even though it's a class attribute and not an instance attribute. Okay, so this is kind of similar to the relationship kind of between the local variable and global variable. So when we look at the name inside the function, it looks for that name or that identifier inside the function in its local variable first, and if it doesn't find it, it might be able to, it will look it up in the global scope, and if it finds there, then it will use that, right? So this is similar to that. Now, so what does that mean for our the dunder init method when we want to increment the class attribute number of cars? Can we do this instead of saying car dot number of cars, car dot number of cars? Can we do self dot number of cars and self dot number of cars? So let's try it. Let me just remove this. And I'm going to run this one more time, right? Number of cars, we created 2 cars. Now, if I change self to self, okay? Actually, take a moment to think about this line of code. And given everything that we've talked about so far, we actually should know if this is going to work or not. So pause for a moment, think about it. Is this going to work? Okay, so let's try it. Number of cars is 0, so it does not work. Why? Why is that? Okay, so let's look at the self.number car on the right hand side first. Okay, so remember this is a re-access, right? And we just said that when the lookup doesn't find the attribute in the instance, it will look for it in the class, and then it will actually find it in the class. The class car has a number of cars attribute. So this one refers to the class attribute number of cars. However, the self.number of cars on the left hand side of an assignment operator, it's right access, and we said this earlier. When we do self dot attribute on the right hand side, on the left hand side of an assignment operator, we always create an instance attribute, right? Because this is self, this is instance, and dot attribute, okay, and it is on the left hand side. So this one is an instance attribute, and we assign the value to a newly created instance attribute. So this does not refer to the class attribute at all. So that's why it doesn't work. Okay, so we cannot do this despite the fact that these two expressions, self.numberCar, self.numberCar, despite the fact that they look the same. The one on the left-hand side refers to an instance attribute, and the one on the right-hand side refers to the class attribute. Okay, so I know this looks very counterintuitive to some of you, perhaps. Actually, it totally surprised me when I first learned about this. So it's normal if this just looks odd, but that's the way it is. And it is actually kind of similar if you remember when we want to modify from inside a function. If we want to modify a local variable, we have to do something special. We cannot just put the name of the global variable on the left hand side and modify it. Okay, so this is kind of, at least it's consistent in that way in Python, that it's more work when you want to modify something that's not in a function scope or method scope. Okay. Well, actually, the next sentence, we're going to do a little exercise in a bit. Okay. So here's so I've talked, we talk about this. Then think through this code fragment here and think about what it would actually print when we run it. So I mean, you can run it, but after thinking about it for a moment first. Okay, hopefully it you come up with an answer that matches what it actually prints out. So bar is the class attribute, right? And when we create an instance of foo, and when we want to print out the class foo bar and then the instance foo dot bar, at least at this point, at this line of code, both of these refer to the same class attribute, right? Because again, instance foo dot bar, when Python looks up the bar attribute, instance attribute, it couldn't find it because it has not been created. It will look to the class and find the class attribute bar. However, when we run this line of code, we create an instance attribute bar in the instance foo. Okay, so when we come to this line of code, foo.bar, it has an instance attribute bar. So and then, but obviously class foo.bar still refers to the class attribute. So these two attributes at this point is different because of what this line already did. And that's why when we print out the result, the second print, the two has different values. Okay, so this is it's interesting. Again, it might be a little unintuitive or counterintuitive, and please do kind of study this very carefully, and hopefully it will make sense. All right, so here's a summary. Class attributes, for most of the time, you should access it by dereferencing the class. class.attribute. Okay, now if we want to read it, there's another way to read it, as we see, and that is accessed by dereferencing an instance. But of course, that assumes that the instance doesn't already have an instance attribute that has the same name as the class attribute. Right, and the main use for this case, and I've done it myself, even though it may not be the most it may not be the clearest way of access a class attribute, is when we try to access the class constants. Sometimes I do go through the instance instead of the class. Okay, now when you want to modify or create a class attribute, then you must access them by dereferencing the class. Okay, I think that's the end of this video. Thank you.